So I'll just give you example of some of the application of the properties that we have learned so far regarding the delta function. So suppose you want to find out what's the integration of 5 e to the power minus 3t cos 10 pi t plus pi over 3 delta t minus 2 dt. So suppose this one is from 0 to 4, right? So what is the result? What is the result of this integration? So it may look very difficult from the first sight, but I would say that it's very easy to evaluate because you can just apply the property of the delta function. So you delta, first of all, what you have to do? So this is your delta. So this is your f of t, right? So this is your f of t, and this is a delta function, shifted delta function, right? And this delta function, which is located at 2, and fortunately this location of delta is within the span of the integration. So this integration spans from 0 to 4, right? So within that span, right, 0 to 4, so you have a signal, right, and you're looking in the window of 0 to 4, but your impulse is located at t equal to 2, right? So that means your integration limit within the integration limit, your delta or impulse function is located. So the answer will be, that means you can write down that your answer here will be equal to this should be your f t minus t naught, right? So what is your ft? So what is the value of t naught here? So t naught here is actually 2. So this will be ft minus 2. So since you have f of t, oh sorry, I think I did a mistake. So let me just, so the result here will be just ft naught, right? Ft naught, and the value of t naught is actually equal to f2, right? So now ft equal to, as you have seen, 5 e to the minus 3t cos cos 10 pi t plus pi over 3, right? So this is your exponential decaying sinusoid. So you want to find out what is the value at 2, f2. This will give you 5 e to the minus 3 into 2 cos 10 pi, value of t equal to 2 plus pi over 3. So we should have now 5 e to the minus 6 minus 6 cos. So you have 20 pi plus pi over 3. Now if you find out this value, then it is 0.0062, right? So this is the answer. The answer here is f2, which is actually 0.0062. 0.0062. So this is the workout of this example. So let me just say a little bit more about it. So suppose if you have a function ft, right, and you want to find out its value at t minus 2, but now your limit is from 0 to 1. What will be the answer? Answer is basically, and because the delta is located at 2, but your integration limit is 0 to 1. So within this limit, this delta function is not located. So basically, you know, this will not have any value, because your impulse is located. Your impulse is located at 2, and you are integrating from 0 to 1, and within that 0 to 1 there is no area. So which is that means the value will be equal to 0. So when you have an integration, you should have a numerical value, a single numerical value. But when you don't have any integration, for example, if you have just f of t delta t minus 2, then what will be the result? F of t. So this is f of t. Let me just write it. So f of t delta t minus 2. So the result will be an impulse. Always remember this. When you don't have an integration, you just multiply a function with an impulse. You always get an impulse. Only difference is that it will have a different strength, and in that case the strength will be the value of the function you evaluate at t equal to 2, right? So always remember this thing. So it will not be 0, it will never be 0. Only thing is it may be 0 when you have an integration and your location of the impulse is out of the limit of that integration. Again, when you multiply any function with an impulse, you get an impulse with a different strength. The strength of the impulse will be the value of the function where the impulse is located. So again, let me just write it down. To the strength of the impulse. The strength of the impulse is the value of the function where the impulse is located. So this basically concludes the topic of impulse function. Now we'll introduce you another signal, which is known as unit step signal, and that is also very important signal. So here we introduce another new signal, which is unit step signal or function. We call it unit step function, and we use very special notation to denote this unit step function, which is u of t, like delta of t, rectangular t, and similarly you have u of t, and this represent a function. Let's define that. So this is actually u of t equal to 1 whenever it is greater than t, the t is greater than 0, right, or greater than equal to 0, you can say greater than equal to 0, and it is 0 elsewhere, right? So it implies, so now if you want to draw this, let me just draw it here. So if you draw it, so this is your t, and you want to draw u of t. So you understand that this is actually 0 for t less than 0. So here elsewhere means the case of t less than 0. Because t greater than equal to 0, it is 1. So when the t equal to or greater than 0 comes, then it takes a step and get a value of 1. So here it achieves a value of 1. So that's why you call it unit step. So it is a step, like in the staircase you take a step, right? So similarly you have a step, and in that step the value of that step is unit 1 or value 1 or amplitude 1, and it goes for t equal to infinity, right? So this is unit step signal. So this one is unit step signal. And we use it many places. It's very important signal to deal with, and there are many applications of this signal. Okay, so let's give you some examples. For example, you have a signal f of t, right? You have a signal, any signal f of t, right? And you multiply this signal with e of t. You multiply this signal with e of t. So what will be the outcome? Very easy, right? So since before t equal to 0, the value of ut equal to 0. So if you multiply this ut with f of t, then this is 0, and f of t, even though f of t not equal to 0 here, but you see it will be eventually, it will be 0, right? And then when t equal to or greater than 0, t equal to 0 or greater than 0, then u of t equal to 1. So that means you should have exactly the same value of the function. You should have same value of the function. So here it will be like this. So you see your signal is, so this is, you can say this is f of t ut, right? So very, I mean, in simple language, you can say that if you multiply any signal with e of t, it makes the signal one-sided. That means it makes the signals only applicable for t greater than or equal to 0. And before t equal to 0, or the signal will be basically 0. So so this is a two-sided signal. Two-sided signal, right? Two-sided signal, or we can call this. So you can call this also a causal signal. Sorry, this is called non-causal. Non-causal signal. When it is two-sided, two-sided means it exists for t less than 0 and also exists for t greater than 0. So it exists for this t less than 0, t greater than 0 value of t greater than 0, and in that case it is called two-sided signal. You can, if you want to say that, or it's also called non-causal signal. And here you see this signal is one-sided signal. One-sided signal, and this one is also called causal signal. So from here you can say that ut, multiplication of ut, multiplication with ut makes a non-causal signal, causal. So if you have a signal which is two-sided, if you multiply with u of t, you get a causal signal which is only exists for t greater than or equal to 0. So causal one-sided signal or causal signal means it exists for only t greater than or equal to 0. So this is one of the function that it makes a signal causal. U of t multiplication with ut makes a signal causal. So let's try to give other examples or application of u of t, and this is expressing expressing pulse with respect to e of t. With respect to expressing pulse with respect to e of t. So let's try to see what happens when you have a pulse. So suppose you have a pulse. So let me just use another color. So you have this pulse. You have this pulse. And this is suppose this is a pulse p of t. You can say p of t, and then this is from 0 to a, right? And it has an amplitude a. So question is that express this pt, express pt with respect to ut, right? So how do you do that? And it's very easy to do that with respect to ut. So you see here, you can say here, you can. So this is actually combination of two unit step function. So one unit step function. Let me just make a equal to 1, so it will be easier for you in that case. So suppose this is just 1. Okay. So in this case you should have, so let's so this is a unit step function e of t, right? And there is another unit step function at shifted at a, right? Shifted at a. So this one you call it shifted function ut shifted by a, ut minus, right? Ut minus. So now if you subtract minus ut minus, what you should get? If you subtract this one, if you subtract this one, right, from this one, then what you should get? What you should get? So at t, okay, so this is 0 because both of the function e of t and ut minus a, they have 0. So 0 minus 0 is 0. Then as soon as you crosses t equal to 0, ut is 1, ut minus a equal to 0. So that means you have 1 minus 0, so you should have just 1, right? And after, when it hits t equal to a, both ut and ut minus a, they have value of 1. That means 1 minus 1 is 0, so it makes it 0. So you see that precisely this becomes a pulse of p of t that we have drawn in the beginning, right? So it has a magnitude of 1, and this is basically p of t, and that means this pulse p of t is actually ut minus. So in this way you can say that you can use unit step function to represent a step, to represent pulse. Unit step function to represent short duration of short pulse, or duration of any a pulse with any duration, right? Okay, so another example maybe you want to see. So let me just show you this one. So another example here, you have, so for example, I draw a signal here. And the signal is maybe this one. So this is for -1. Okay, let me draw it another color. So this is, and this one, suppose, right? So, and this is t, this is t. So suppose this is function of t, and how it express, if I ask you to express that, this signal with respect to this, so express this signal. The question is that express the signal, express f of t. So express f of t in terms of u of t, right? So how do you express that? First of all, you see that f of t has two parts, right? So we call it piecewise function. This is called piecewise function. Why we call it piecewise function? Because it has one piece here, you have another piece here, then it becomes 0. So it has basically two pieces. So that's why we call it piecewise function. So in the first case, you have a signal which is a basically straight line, equation of straight line. So -1, and then it is 0 here, right? And then it is +1 here, and magnitude of 1, this is 1. So you can say that f of t, so what is the equation of this straight line? What is the equation of the straight line? So you can easily find it out, right? So this one has a value of minus, okay, let me just, so it has 2, you can find it out in many ways. So another one of the ways is it has here the coordinate is 1 and not 1, so 0. Okay, let me just, so this is basically, it has a x coordinate is 0 and then y coordinate is 1, and here you have x coordinate which is -1, y coordinate is 0. So -1, 0 and 0, 1. So these are the 2 points. So you have a straight line which goes through these 2 points, -1, 0 and 0, 1. So what will be this equation? So you know that y minus y1 minus y2 equal to x minus x1 divided by x1 minus x2. This is, you know, from your college background or HEC background. So y minus y1. So y1 equal to, so let me just, so this is your, maybe you can say that this is your x1, this is y1, this is x2, this is y2. So that means you should have y minus y1 equal to 0, and then you have 0, and the value of y2 is equal to 1. So similarly, x minus x1 equal to -1, and then you have x1 which is -1, and x2 which becomes 0. So now if you simplify that, so you have y minus 1, x plus 1 minus 1. So you have y equal to x plus 1. So this is your equation of the straight line. So I think this equation, straightening the equation is correct, because if you put x equal to -1, it makes y equal to 0. If you put x equal to 0, it makes y equal to 1, which basically are the two points in xy coordinates. So now if you want to write down this in terms of because your function is not in terms of x, it is with respect to x. So what you can write here, let me just do it here. So you can say that your f of t is equal to, instead of x plus 1 you should write t, because the coordinate is in terms of with respect to t, it's not x. So instead of x you should write t plus 1. So when it is valid only when t is in between -1 and 0, and it is equal to 1, f equal to 1 when t is in between 0 and 1 and 0 elsewhere. So this is, you write the equation of the f of t, which is a piecewise function, and that's why you get different interval of t in different cases. Now you want to use unit step function to represent this f of t, right? So that you can do here. So let me just, so you can actually write down these things. Let me just write down. So f of t is equal to t plus 1, but you should write down this ut plus 1 minus ut plus ut minus 1. So this gives you, so how you can write this? How you can write? So this is basically your answer. This is your answer of the. So you express f of t in terms of ut, but you can simplify this further. But if you write this much, that should be okay. But why is it so? Why? How you can write this? So if you explain, if you want to explain that, you see here, your function has two parts, right? So first one is you have a straight line. You have a straight line, right? And that straight line is this one. So you see here, an equation of this straight line is t plus 1. But this is only exists for the case of -1 to 0, right? So to limit the duration, what you want to do, you want to use a pulse, right? You want to use a pulse. You want to use a pulse to represent this time limited signal, so which exists from -1 to 0. So since it exists from -1 to 0, you want to use a pulse from -1 to 0. So as you know that we have shown you that when you have this pulse, right? So you start from 0 and ends at a. You know that you can write it as ut minus a. Similarly, if you have a pulse, suppose from A1 to A2, what you should write? So you should write as ut equal to, so this function you can write so you should write as ut minus, start at A1, right, and ends at A2. Okay, so a pulse with duration starting point from A1 and ends at A2, you should write that ut minus a1 minus ut minus a2. So a1 is the starting point and a2 is the end point. So similarly, if you have this pulse, you see, so you can write this pulse. The starting point is -1. So ut minus starting points -1 starting point, and the end point is 0. Ut minus 0. So that means this pulse is ut plus 1 minus ut. So now if you multiply the straight line, the equation of the straight line, which is this straight line, you see here, this straight line here, if you just write down an equation of the straight line, so let me just do it again here. So you have a straight line going through these 2 points. So this straight line is actually, this is this straight line, and it goes for any value of t. It goes for any value of t, from minus infinity to plus infinity. But you want to limit it from only -1 to 0. You want to limit it from -1 to -1 to 0, right? So in that case, you should multiply this with a time limited pulse, which is ut, in this case, which is ut plus 1 minus ut. So you multiply this signal with this pulse, right? And this will give you, so this will give you this thing. This will give you only this much, right? Only this much, because the other place it will be 0. So this one, if you want to write it, so this is t plus 1 ut plus 1 minus it, right? So this is this part, and this part is straightforward. This part is straightforward because it is start at 0, so ut ends at 1, so ut minus 1, right? Ut minus 1. So and that constitutes the second part, right? So now this is your result. Ultimate result is f of t is equal to ut, sorry, let me just, so t plus 1, right? T plus 1 ut plus 1 minus ut, and then you have just ut minus 1. So ultimately you have t plus 1. You can a little bit simplify it if you like, minus t plus 1 ut plus ut minus 1. So now you can a little bit simplify t plus 1, and then you can write, so this is minus t ut minus ut plus ut, and then minus ut minus. So this one, they cancel out. So you can basically write t plus 1 you can write t plus 1 minus tut minus ut minus 1. So this is the answer. But if you just write down this much, that should be okay. You'll get full marks, even though if you don't do any simplification. So next we'll do the ramp signal. That will be the last example of the signal modeling. So ramp signal is ramp signal. If you want to draw the ramp signal, let me just draw it first, then I'll explain that. So this signal, it increases with unit slope, and you use a particular notation R of t. Like U of t is the unit step signal, R of t is the we call it a ramp signal. So ramp signal is basically which increases with respect to time for t equals or greater than 0, equals to 0 or greater than 0. So if you write it down mathematically, R of t equal to, so this is equal to 0 for t less than 0 and equal to t for t greater than equal to 0. So this is the definition of ramp signal, right? So let's try to use this for example in this case. So suppose we have this signal 0, 1, 2, 3, and a signal increases with unit slope and then flat it, and then it becomes, so let me just use another color. Yes. So this is a function of t. So question is express f of t in terms of in terms of u of t, r of t, so r of t. So how you can do that? So you see that this is also a piecewise signal. This is also piecewise signal because the signal is 0, so you can write it down, piecewise signal. So the signal changes with different intervals, right? So you can write f of t equal to 0, right, when t is less than 0, and then it becomes with slope 1, that means t increases t, so when t is in between 0 and 1, and then it becomes again 1 for t from 1 to 2. Then it has, so what is the equation of this signal? So you can show that the equation of the signal is, so this one is the equation. You can write this f of t is equal to minus t plus 3. You can easily find it out, right? So that means you can write down here is this is minus t plus 3 when t is in between 2 and 3, right? So one thing is that you should not, if you use, let me just, you should not use equal to in, so you can write it down like this, right? Anyway, so but how you want to use a ramp signal to represent that? A ramp signal to represent that. Only ramp signal. You can use, of course, you can use unit step signal to represent this one. Very easily you can use unit step signal. But for ramp signal, you need to a little bit tricky. This part is a little bit tricky, but it is doable. So what you can do actually, so let me just draw it here. So the first part, if you have just a ramp signal, right, it will increase, right? So this will increase, but you see here your signal is, it becomes flat, it becomes like flat here. So that means you need to make the signal flat here. So the solution for that part, you should use a ramp signal. So this is one part, R of t, this part is R of t here. This part you can say that this is R of t, right? But it becomes flat here. So what you should do here, you should add a signal, the negative slope. So this signal here now, so this one is actually R t minus 1, but with a negative slope, right? So what will happen now, this, if you add R of t with this signal after this point, because this is a delayed uh, this is a delayed part, a delayed ramp signal with a negative slope. So after point 1, as it increases, also if you add this, the second part, it will also decrease. So it makes your signal flat. It makes your signal flat. So now you have this part before 1, because you have only 0 here, right? So if you add this RT minus 1, then you should get this part and then this flat part, and it will go forever, right? But what you want to make, after 2, you want to make it like this, right? And then, so how do you do that? So the solution for this part is the following. So you have, after, so this is 0 1, and then you have 2, maybe this is 2, so this is 0 1, this is 2. So after 2, right, after 2, what you want to do? So after 2, you want to increase it with a negative slope, right? So what you should do now? So you should add another ramp signal here, right? You should add another ramp signal, sorry, another ramp signal. And this ramp signal, you see, if you add this, so this is actually, if you want to write it down, so this one is minus t minus 2. So if you now add this minus t minus 2, after 2 it will add, it will basically make the straight line, this straight line, it will make like this. So it will so it will make your signal, not this one, it will make lower down the signal, because you are actually adding some negative values from this point. Now again you have a problem that if you just have, if you don't add anything, then it will go all the way this way. So to control that part, you want to use this part. So after, so you have 0, you have 1, you have 2, you have 3. So after, after 3 you should add ramp signal, this one. So this will make the signal this way. So basically you should have now, instead of this one and this one, you have a signal which is this, and this, right? So this part will make this part 0. So the equation of this one is R t minus 3. So you can write down f of t. Let me just write down. So you can write down f of t. F of t is equal to f of t equal to r of t, then minus rt minus 1, then minus rt minus 2, then plus rt minus 3. So this is how you can use the ramp signal to represent this piecewise signal or function, piecewise function.